In this video, I will show you how to solve exponential and logarithmic equations. Well, the first thing you want to do on a problem like number 1 here is to use the product rule, which says that if you take the sum of two logs, you can condense them into a single log if you make it a multiplication problem. So this would be the same thing as the natural log of x plus 2 times 3x minus 2. Alright, and just to be clear, all of this is within the argument of the natural log. It's inside the natural log. And so that will equal 2 times the natural log of 2x. So of course we want to go ahead and multiply these together and see what we really have here. So let's see, natural log x times 3x is going to be 3x squared. Inner we have 6x, outer we have negative 2x. Together that's 4x, and then we have minus 4. So we have that. And that is equal to 2 times the natural log of 2x. Now I'm dying to make an equation that does not involve this natural log so I can solve it. The thing that's messing things up for me is this 2 in the front. If this wasn't there, I could set everything inside of here equal to the 2x, and I could go on about my business. But how do I do with this 2? Well, you can use the power rule. The power rule says, for example, 2 times the log of n is the same thing as the log of n to the second power. So the power rule says if you have a coefficient, you can make it the exponent, or if you have an exponent, you can make it the coefficient. Okay, so I can take this coefficient and make it the exponent. I can take this and move it, and it can become the power. So just be careful, because this is going to become the natural log of 2x to the second power. It would be an easy mistake to make to just put the 2 as the exponent of the x. But everything inside of here has to be squared. So really what I'm going to have is the natural log of 4x squared, not 2x squared. Okay, so this is going to become the natural log of 4x squared plus 4x minus 4. Now that we have natural log, we can set the arguments equal to each other. Next, we would put everything on one side. Now, I really want x squared to be positive, so normally I would subtract 4x squared from both sides, but that'll make negative x squared. So I would prefer to just plain subtract the 3x squared from both sides, just so everything stays positive. So then I will subtract 4x from both sides, and I will add 4 to both sides. So that's going to give me 0 is equal to x squared minus 4x plus 4. Now at a glance this seems factorable. So x squared is x times x. 4 is 2 times 2. I want the middle to be negative 4, so that will be negative 2 and negative 2. So that's how you factor it. Setting either one of these equal to 0 yields x equals 2. Alright, so this is probably the answer. We just need to make sure that substituting 2 back into the original equation doesn't give us a negative number. If I you can't take the log of a negative number, or 0. If you put 2 in here, that's 4, so that's fine. If you put in 2 here, that's going to be 12, and then that's going to be added to 8, So that's 20 minus 4, so that's 16, so that's fine. Alright, so the answer is x equals 2. Alright, here's another interesting problem. How do I solve a logarithmic equation such as this? Well, if it weren't for this 2 sitting in the way, I could just set the x minus 12 equal to x minus 2 and just go to town algebra 1 style from there. But the 2 is there, so I have to deal with it. Now, what I can do is this. Let me recopy the rest of the problem. So I have log, and understand this is an invisible base 10. But anyway, I have log x minus 12 equals 2. And I'm going to leave a little bit of space here. You'll see why in a minute. Plus log of x minus 2. Now, I can put log 10 in right here without changing the value of the equation. And that's because log 10 is really log base 10 of 10. And a log is just a power. It's the power that turns 10 into 10. So the log base 10 of 10 is just 1. So when I write log 10, this really just has a value of 1. And of course 2 times 1 is 2, so I haven't changed anything. So this is legal. Now why did I do this? So I'm trying to turn this 2 into a log expression that has the same base as all the rest, so that I can combine these together and move forward with my calculations. So what I can do now is I can do the power rule, which says if you have a coefficient, you can take that coefficient and turn it into an exponent inside the logarithm. So this would be the same thing as log x minus 12 is equal to log 10 squared, okay, plus log x minus 2. And of course, next chance I get, I'll make that into 100. In fact, maybe I'll just do that now. You've seen it, you get it. It's 100. Okay, so now what I can do is I can use the product rule. The product rule says that if you have the sum of two logs, you can write that as a single log if you do multiplication. So this would be the same thing as a single log of 100 times x minus 2. So we'll just wind up doing the distributive property over here, but first let me recopy this. So I've got log of x minus 12 is equal to log of, and this will be 100 x minus 200. So now we got the log of something equals the log of something. So the arguments, meaning the stuff inside the log, must be equal to each other. So x minus 12 must equal 100x minus 200. So let's get the x's together. I like this part to stay positive when I can, so I'm going to go ahead and subtract x from both sides. So that gives me negative 12 is equal to 99x minus 200. And then I will add 200 to both sides. So that's going to give me 99x is equal to 188. So that means x is equal to 188 over 99. So that is the answer to problem number 2. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.